Hello everyone, and thank you for joining us. My name is Gisela and I will be the host for today's webinar. Before we dive into the content, let me cover a few housekeeping items. At the bottom of your screen are multiple application engagement tools that you can use. All these engagement tools are raisable and movable, so feel free to move them around to get the most out of your desktop space. You can also expand your presentation area or maximize it to full screen by clicking on the arrows in the top right corner. If you have any audio or video issues, you can find answers to some common technical problems located in the Help widget at the bottom of the screen. Please note that the copy of today's slide deck and additional resources are available in the resources list. Please have a look and download everything that you may find useful. On top of this, the webinar will be recorded and sent to the email you registered with. Lastly, if you have any questions during the presentation, you can submit them through the Q&A widget. We are here to answer you live in the chat, so don't hesitate to reach out. If we run out of time or we don't manage to answer your questions, we will be sure to follow up later by email. Now, I would like to hand it over to our speaker, Brian Kennedy.
Thank you very much for that introduction, Gisela. Again, my name is Brian Kennedy, and I'm a solution consultant here at Jama Software. And today, during today's webinar, I'm going to be discussing the process of unlocking the power of the digital thread in Traceable MBSE. To begin with, let's kind of just take a step back and understand what exactly is the Traceable MBSE process and where did it originate from? Today, many products that companies produce are life or safety critical. And one of the requirements for life and safety critical products is that the company must completely document how the product should perform. And additionally, they have to also prove that it performs as specified. As products have become much more complicated and sophisticated and systems have become much more integrated and difficult to model, doing this process has become a greater challenge than it was maybe previously. As a result of us interviewing various engineering leaders who are responsible for product release, we asked them, what keeps you up at night? What are the top things that these engineering leaders say keeps them up at night? And as we listened to them, we heard many common questions kind of come up. And these are the 5 top questions or issues that they kind of indicated. The first one is, how do I know which product requirements have been missed in my design? How do I know which product requirements are not fully covered by my test cases that I've defined? How do I know which product requirements have failed to pass tests? And how do I identify development activity that happens to be using incorrect requirements, or maybe isn't even covered or isn't even directly connected to requirements? And finally, how do I know if changes that have been made in, say, hardware impacts my software team, or a requirement change impacts either the hardware or software team? How do I understand this traceability? These are the things that we've heard a lot about. I bet you one of these might resonate with you. I'll tell you what, why don't we take a quick survey? There's going to be a survey that pops up, and we'll give you a couple minutes to kind of walk through these questions and tell us which one of these questions do you identify most with or is most pressing on your needs. Thank you very much for answering which one of these questions is the one you most identify with. At the end of this presentation, we're going to come back to each one of these questions and show you how traceable model-based system engineering processes and the digital thread can help address each one of these items. So let's talk a little bit about how we have developed Traceable MBSE to address these situations. To start with, let's talk about where we came from. And we came from a paper-based system, and it doesn't fully address these questions that we have here. And so in order to solve these problems, we've performed a digital transformation. And that started with a very simple thing a long time ago of actually switching from physical paper over to electronic files. This provided significant improvements in efficiency and allowed us to each domain and discipline to be able to capture their data electronically versus in paper. It does improve communication, allowed us to share data easier, allowed us to reuse data in a much easier process. But fundamentally, this first step of converting from paper to electronic file, although it was a huge advantage, it didn't fundamentally change the process in which we did system engineering. We were still stuck with disconnected data. So the next phase in this is what I call the decomposition phase. And this occurred where we actually took those individual documents, for example, a complete requirement specification, and decomposed it to individual items. And this was very powerful. What we were able to do is, instead of having a single document with all the specifications in it, we would decompose it to individual requirements. And each individual requirement could be referenced independently. And in fact, they allowed us to reuse this data and such. So you could have the same requirement being reused in multiple places, wherein before you literally had two separate pieces of text that you were duplicating. Once again, another huge improvement in efficiency. And this concept of decomposition isn't just isolated to requirements. It was implemented in various other things, such as the modeling systems for various other things. And it ended up creating a capability so that each discipline, each domain, was able to create unique tools that address decomposition or analysis or simulation of their particular areas. So what we saw was requirements identification and subsystem requirement identification being executed in Word or Excel spreadsheets initially, and even going into some modeling techniques and different tools. So we ended up with a verification validation process that for each individual domain, we were able to create some decent automation, but they weren't connected. Each group was kind of independently looking at their data and creating it, and there wasn't consistent reuse across it, and no consistent way of knowing what was the correct stuff. We depended on things like email and such like that. So it really created impact on things like a lack of ongoing risk assessment, and change management became very difficult, because even though we had decomposed some of the things and we had captured all the documents electronically, we still were not interconnected. We didn't have a uniform interconnectivity. And this meant we had to take one more step in our digital transformation. And that final step was to create a true full model definition. And when we talk about creating a full model, it involves quite a few things. First is governance. We have to create a structure and version control on top of the data. So we would classify the data in groups and control each one of those individual items, requirements, simulations, functional definition, architectures as individual items, and version control them in a controlled system in a database framework. So we had a governance structure and control framework that needed to be defined. We then expanded from just having text-based or static images to having full diagrams where each items were interrelated and connected together, and we were able to create visual diagrams that illustrated how our systems were being designed, how functions and subfunctions and systems and subsystems were supposed to interact, and how data was supposed to flow from one part of our system to another. And we created these diagrams. And finally, we created a common data model, which allowed us to capture all these different pieces of data and define relationships from one item to the other, and have consistent terminology and consistent use of that data. So we had one requirement defined in one place, and it was used wherever it was needed by referencing that single item. And so that's where we talk about a data model. We needed a complete data model to capture all this data that we were governing in the governance area and in the diagrams. So this really illustrates what we were trying to accomplish when we transformed from a document-based system to a traceable model-based system engineering framework. And here are the key benefits that you see. In the old document-based scenario, information was mostly text, and it was very loosely coupled and often repeated in multiple documents across multiple scenarios because of you needed to view it in slightly different ways. In the model-based system version of things, we see both visual and textual information. Constructs are defined once and reused over and over again. We don't have to repeat data over and over again in a disconnected fashion. The data can be shared across all domains. We have consistency in our notation and diagrams, and we have defined relationships that tell us how data should move from one section to another and what things are related to what. So we understand which requirements are related to which functions, which are related to which development activities. We also have information views that no longer are document centric. We can now provide multiple viewpoints into the same data. We can filter data dynamically and provide more of an exploration of the problem space in a very rapid fashion. Where in the document viewpoint, a lot of that was static and required a tremendous amount of manual work. Measuring change impact. This is probably one of the biggest benefits that we have for this concept. And that means that looking for change, we had to walk through multiple documents and often look for text requirements and figure out how those are related from isolated structures and behaviors across the system. It's very difficult, very time consuming. Now with model-based, the relationships are defined, and so you have defined traceability paths.